Okay, good day everyone. Thank you for attending and welcome you all to our June version of our webinar series that GL puts on every month. And we're excited about this month's topic. We get excited about these webinars every month actually. It's a good way for us here at GL to sort of organize our thoughts and present topics that are relevant in the industry and relate our products to those topics and so forth. This month we're talking about emergency services we're in that industry. So the title of it is Testing Emergency Call Services, 911, Enhanced 911, and Next Gen 911. So we're going to be talking about a variety of things from CAMA trunks to new 911 services, mobile location services, and next-gen services and so forth. So we're going to go in a lot of directions here. We've got a lot of material to cover, and we'll try to get through it. And if we don't, we will maybe have another webinar in the future on some of the things that we haven't covered. So I'm joined. My name, by the way, my name is Matt. I'm joined by my colleagues Vijay and Sanjeev. Vijay will be handling most of the technical discussions today, and Sanjeev is helping with the administration of the webinar. If you are not familiar with GL, I'll give you just a very quick overview. We're located in the United States. We're in Gaithersburg, Maryland. That's our headquarters. We were founded in 1986, so we're a very well-established company here. We do a lot of things here at GL, a lot of exciting things. We are involved in engineering consulting services for local, state governments and federal governments, as well as the main bulk of our company here is with test and measurement equipment. So we have been providing commercially available, in-house grown hardware, software, test and measurement equipment for a very long time, since the early 90s. And we have a variety of products in that whole arena. They span in the wireless industry, voice over IP, legacy, TDM, two-wire, and so forth. Our sort of claim to fame on all of our products is we are PC-based, so very easy to use our products. The interface is very friendly, and it's portable usually, and it's very cost effective. So if you haven't been familiar with GL, that's a little bit about who we are. So to get started into our webinar today, we just thought we would throw up a little bit on the background screen here, and these are just a few thoughts to consider as we get started here about this subject. And they may seem a little random on the thoughts, but all of these are notes that we thought people in this industry should know and consider. Obviously, one thing that we all know is rapid emergency services are essential, and that's been mandated here by 2021. 80% of the time, we need to be able to locate these callers within 50 meters. So some of the new technology is very well on its way to doing that. Some of it's already able to do that, but that has been mandated. FCC has mandated it. A couple other notes here. Traditionally, landline phones, if you go back years, landline phones were predominantly used, and the location was a fixed location. So database lookup was very easily done. Your address was in there, and that was how it was done. Nowadays, as we all know, mobile phones are taking over, even in the business locations, business office buildings, and so forth. VoIP phone service has taken over. So challenges with all of that are need to be addressed and are being addressed. But as we look at VoIP phones in an office building, it becomes a challenge on which floor that's coming from, which office is it coming from. They're big buildings, and so forth. So these things are all being addressed and talked about, and there's plans moving forward. And GL is involved in trying to understand all that technology and testing for that technology. So as we talk about mobile phones, we read something here recently about 75, maybe 80% of all 911 calls are now coming from mobile phones. So this provides a challenge on where the location of these phones are. I mean, it's very variable in that sense. You're mobile, and you're in a building, you're outside, and so forth. So these technologies with GPS within the phone, cell tower location technologies, even Wi-Fi hotspots are being used. So these are the types of topics that we're going to get into. And when you look at TTY and TDD, or relay for the deaf, so hearing impaired provisions are part of emergency services, and they need to be considered as things move forward. And that kind of leads into the text to 911 becoming available. So as mobile phones are predominantly used, texting to 911 is becoming available. Very important. And as I mentioned, almost all mobile phones have GPS, so that location can now be transported to the PSAPs, so that the emergency services person is now able to know exactly, pops up right away where that person is, where that caller is. And so those technologies are changing. I think VJ is going to jump in here in a minute and talk to you a little bit how those things have been evolving and changing. And I will let him take over here in just a second. One thing that I wanted to mention right before we hand off to VJ is an example of recent news that probably you've heard about. Apple made some announcement here in mid-June that with their new iOS 12, they are going to be teaming up with a company to try to provide this location and emergency services contact information for their users, for their phones. And they've got they have a location service called, they call it Hello, I think, HELO, and that is, they use a variety of methods, GPS and Wi-Fi hotspots and cell tower technology to locate that phone. But then all of that is being transported, what we call over the top, to the PSAP in a nice, neat little package there. So this is going to allow responders to very quickly know where you are and have a lot of more information about the caller, the person in trouble, their contact information, maybe their emergency contact people to call on behalf of you, and so forth. So a lot of things, you can dream up what that would be, but all of that information will be available quickly to the responders. So that was just an example of some recent news. I think that just happened in mid-June here. You probably heard that. So at this point, I think I'm going to hand over to VJ and allow him to take over, and he will get into some of the 911 landscape.
Well, first of all, thank you, Matt, for that very good introduction, and welcome everybody. I've done a few of these, but I think I may be rambling on. Matt's going to try to control me here. But first, I think one of the things that you may have noticed is that this 911 emergency services arena technology has a lot of acronyms associated with it. And let's start off with one of the most basic acronyms, which is really very confusing. It was confusing to me when I was a young engineer. It's called CAMA, C-A-M-A. And the first question, that comes to mind with any new engineers that are in the telecommunications is, what does CAMA mean exactly? And it is always used in the sense along with 911 emergency services. But actually the acronym means Centralized Automatic Message Accounting. And it was really an old legacy technology that AT&T had introduced for billing purposes for when they provided enterprises with PBX services. So they did not only did they provide the telephone service for an enterprise, but they also provided the billing for it. And they had invented this this way of providing the the number of the phone and the billing information, the minutes, etc., for that phone. So this was it was called CAMA, Centralized Automatic Messaging. But however, that technique of sending caller ID information or calling number information along with additional information was very valuable and was adopted for 911 services. And so that's why the term is stuck. It's a two-wire analog trunk, and that's another area where a lot of confusion arises, but I'll get into that in a few minutes. So the word CAMA is, although it means, has this acronym, it really has to do with the method of transmitting information about the caller identity, the calling number, and information about that, which can be used, as Matt had mentioned, by looking that number up in a database. You can get the street address. You can cross-reference the street address. So that's a very useful methodology that was adopted from this CAMA protocol, that very simple protocol that used essentially dual tone multi-frequency or MF frequency tones to transmit caller number, the calling number rather. Okay, and here's another term, selective router, that is used in the legacy 911 world, which is still very much in play here. And people are, the new carriers are going to have to interface with these selective routers, whether they are the new generation or the older generation, which know where all of these PSAPs are. PSAP, what is that? That's a public safety access point. And that is the place where the attendants are that service an emergency call. They answer your call. They're supposed to be calm, collected, take the emergency information from people who are under distress, and dispatch emergency vehicles. So public safety access point is another terminology that is prevalent in this industry. ANI is another number, automatic number identification, and that is the actual calling number, whether that could be a mobile number, a VoIP number, or a landline number. When it's a landline number, it's pretty easy to cross-reference it to a street address through some sort of a database lookup. If it's a mobile number or a VoIP number, then of course there's some ambiguity about the exact location of that number. It could be anywhere, right? Mobile phones could be, for example, even out of the country. But the mobile network is very good at getting real-time information about the location. In fact, that's one of its prime functions. Because if you remember early on, mobile phones, the very important function of mobile phones is roaming, meaning the ability or handoff. For example, handoff, roaming, they're somewhat similar. Handoff means you have to know the exact location of where the mobile phone is so that the call can be continuously processed or handled while the subscriber jumps from cell to cell. Similarly, if he's roaming in a separate carrier space, he needs to be located and the call needs to be routed appropriately to reach his location. So the mobile industry is very good at locating in real time the exact location of a mobile user. Similarly, in the VoIP world, a VoIP technology can also track a user by the processes of proxy registration and so on. So these database methods are part of these new technologies, and partly they're there because the FCC has mandated that emergency services are mandated for all carriers, whether you are PSTN, old legacy PSTN, mobile, or VoIP. In fact, I think they're also requiring it for satellite-based carriers as well, for when you're talking over satellite. Okay, so that's some terminology that, excuse me, that keeps coming up that you need to get familiar with. Okay, so let's go to the next slide here. And we're going to get into the very basics here. And this is an area where I know when I was a young engineer as well, I was very confused about what is FXO. You've heard that term, FXO and FXS. And these are the two-wire loop technologies. So a normal subscriber, I've drawn a little for you electrical engineers who are interested in exactly how things are implemented. A telephone is connected to a central office through what is called a local loop. So that's tip and ring. And usually the phone is powered by minus 48 volts so that you don't have to worry about losing power in your home. You still have telephone service. So this same technology, this two-wire loop start technology, was used for emergency services. And in fact, it's called a CAMA trunk. And so a CAMA trunk is what is used, and it uses a form of two-wire loop start technology. But however, there are some differences. So in two-wire loop start, which is a regular customer, regular subscriber connected to a central office, you have dial tone. You normally get dial tone when you go off hook. You don't, I mean, at least, of course, now you have things like caller ID and those kinds of things, but initially you didn't have any automatic number identification. You also don't have something called answer supervision. And what is answer supervision? Answer supervision is when you make a phone call on a standard landline, if you're familiar with old landlines, if you still have them, you make a call to your destination. You don't really know automatically unless you get an audible response from the person who picks up whether the call has been completed or not. And so that makes it tough for automatic machines to understand when a call has been completed. You can normally hear an audible ringing that you know that the phone is ringing, and when he actually picks up, the audible ringing stops. So that's sort of, you kind of infer that the call has been completed. So that's what we call answer supervision. So under a normal two-wire loop start, there is no answer supervision. And there's something called a wink in the telephone world, whereby it's an indication from one end to send digits, and that's called a wink. That's sort of a process by you indicate that you're ready to receive digits. Normally, on a two-wire loop, you get the dial tone, which is your indication. It's an audible indication for you to send digits. However, you know, again, in the automatic, when the machines are talking to each other, a dial tone is not a good way to indicate that you are ready to receive some digits or calling information or whatever. So therefore, they use something called a wink. So in standard two-wire loop start technology, there are no winks. So these disadvantages of two-wire loop start had to be addressed if you were going to use two-wire technology for emergency services. You had to address these deficiencies, and so we first, we use this CAMA trunk. So in the CAMA trunk, a lot of these deficiencies were addressed for the CAMA services, because there you were trying to send information about message accounting and so on, or billing information, and two machines were talking to each other. So you had to resolve these deficiencies. And the way they did that is they used something called reverse battery. So normally you have minus 48 volts going to the telephone. So by a method of inverting that 48 volts, the telephone end can recognize the voltage inversion and use that as a method for signaling. So even though there's no dial tone in response to off hook, they use this reverse battery for indication of off hook or on hook. So when we go further into this webinar, you will see our ladder diagrams for our test equipment. You will see on hook, off hook. conventional meaning of on-hook, off-hook is usually, you know, the loop is closed or open. But here in this CAMA business, we use on-hook, off-hook for the purpose of conveying. We convey that through reverse battery, so converting the battery voltage. It's a DC voltage, so it's possible to invert that voltage and recognize it at the other end electrically. So we use that for not only for on-hook, off-hook, but also for answer supervision. So that means that when we when we do the reverse battery, it's an indication of, for example, off-hook or on-hook, depending on what you want it to transmit. Wink is also transmitted in the same manner by momentarily reversing the battery. So those are just some basics that you need to kind of know if you're dealing with analog trunks, which, for better or worse, are still being used in PSAPs. So I hope you've understood that. That's just sort of if you're an electrical engineer, you'd like to know exactly how it's being done, and I for one like to do that. And so this just sets the basics. So I hope you understood that. Now we can kind of get into more details. So let's just take a look at. So here is our current network of how we convey 911, a basic 911 call. So this is kind of a busy diagram, but let me show you what I'm talking about here. At the very bottom here, we have a home, a residence, with a regular landline call, landline telephone. And here the subscriber or the home user picks up the phone and dials 911. Immediately, that's recognized by the central office. If it happens to be an enterprise, they do the same thing. They either do 911 or something like 911. But anyway, it's standardized. And that's the mechanism by which we convey an emergency service. The central office recognizes that 911, and by that number, it routes the call to what is called a selective router, or sometimes it's called a tandem switch. So this is a conventional technology, and whether you are going to new technology or sticking with the old, you've got to be compatible with this, because the PSAP network, the public safety access points, are compatible with this. So whether you go to IP or wireless, you still have to be compatible with this basic technology. Now, as the technology evolves, you can come up with new schemes for data transport and so on. But at least for now, when we're in this transitory period, we have to be compatible with this. So what does the selective router do? Once the call is transmitted to the selective router interrogates a database where it cross-references this calling number, and the calling number is transmitted by the central office to the selective router through what are these called CAMA trunks. CAMA, it can be analog or they can be T1, and here I've also said T1 PRI, but I think that's a mistake there. So either via T1 or CAMA analog trunks, the calling number is conveyed to the selective router through that two-wire trunk methodology that I was just mentioning. And that, with that calling number information that is referred to in a database, is used as an index into a database to get the street address. And that street address information is conveyed to the public safety access point, and the nearest and the designated public safety access point for that particular subscriber. There could be many public safety access points for a geographic area. You pick the right one, you provide that street address information to that public safety access attendant, and he can then converse with the subscriber, the distressed subscriber, and dispatch the emergency vehicle, police, fire, or ambulance. or whatnot. So the same technology is used whether it is in, for example, if we now go from a landline to an IP phone, the exact same mechanism is used. However, now the database is something called a VoIP positioning center. Some other VoIP carriers have their own database terminology, but essentially it's a database that looks up the position of the VoIP phone, and that is again conveyed through these CAMA trunks to the PSAP. And the wireless is, of course, similarly. Now, that is the standard mechanism by which this location information is conveyed to the public safety access point through these CAMA trunks, these two-wire analog trunks if it's analog, and if it is digital in T1, then you have four-wire trunks, and it's a little bit faster and easier and higher bulk capacity. But again, the protocol is the same, whether it's digital or analog. So that just gives you a kind of a setting for how this legacy technology is still used, whether we're transitioning to a new network or we're in the old network. Let me go back here. Now, we did actually have another webinar. Actually, Matt and Savita, one of our colleagues here, had provided a more in-depth webinar on how the protocols within a wireless network, whether it's 2G, 3G, or 4G, how this location information, whether it's GPS-based or cell tower-based or what have you, was conveyed in the protocols and conveyed to external entities. That external entity could be, for example, a PSAP. And that actually gets into a lot greater detail about how it's done exactly, what the protocols are for conveying this location information in real time for wireless networks. It's a tougher task, of course, in wireless networks. And that's what this diagram here is. It just shows you essentially a 2G network there, but it's applicable for 3G and 4G, and it's a much more complicated set of protocols. But they do try to provide real-time dynamic location information, not only for the purpose of managing their own wireless network, of course, because for handoff and for roaming and so on, but also to external entities like PSAPs for location identification for emergency services. Okay, so I suggest that you probably go listen to that to get a better flavor for the protocols that are involved in the wireless network for conveying this information. But as I said, the wireless network is very well equipped to provide real-time, second-by-second location information to external entities. And of course, for that purpose, if it is that dynamic, it does need to be those protocols are pretty powerful or interactive and dynamic. Okay, let's see here. Now, having said all this, I think this next generation technology has to do with essentially getting this location information. There's a standards body called, or standard specification called NENA I3, a National Emergency Authority or Administration that has promulgated these standards, and they are addressing this next generation emergency services where it can be multimedia information can be conveyed, like, for example, text and even video and instant messaging and voice, as well as other forms of media, can be conveyed from a subscriber to the PSAP. Now, this is, of course, is something that has been promulgated, standardized, and carriers and PSAP providers and equipment providers are in the process of implementing this solution, and it's got a long way to go. And Matt talked about other methods that over-the-top, perhaps, or direct handset manufacturers are doing which may or may not be compatible with these NINA standards, but I think they are trying to be compatible. So this is what's happening in the next generation 911. Again, the location information conveyed from wireless or landline networks via SIP, Session Initiation Protocol. And we use the text-based information and multimedia, RTP voice, and so on, ways of conveying this. Of course, you always want to be able to talk to the attendant, so voice is always a necessity, but these, for people who are hearing impaired, texting is important, and there are protocols like we'll talk about later, MSRP and so on, instant messaging and texting, that are identified in this standard that permit you to go to the next generation and provide alternative means other than just voice to convey emergency information. Okay. All right. All right. So now let's talk a little bit about what GL, having established that terminology and general idea about what's going on in the emergency services business. Let's talk a little bit about what kinds of testing requirements there are, considering that we want to be able to either test next generation services or legacy services, whether you want to test the PSAP end of it or the selective router end of it. We want to be able to emulate T1 CAMA trunks, for example. So T1 is a very common legacy TDM technology that can convey the same information according to the protocol that I kind of described to you earlier, that provides this automatic number identification, which is the caller information that can be used for a database lookup and get the street address. So that is a very common method for transmitting this information. The protocol is well established, and our equipment, our T1 equipment or E1 equipment, can easily emulate that in bulk. And so we'll talk a little bit about that going forward. You also want to be able to emulate the analog PSAP trunk, either in bulk or in as an individual trunk. And so both of those features are also provided with some of our test equipment. And it provides the signaling analysis, the digit analysis that is part of that CAMA trunk. And we do kind of do that with the easy to set up GUI or with CLI commands and so on. Okay. So, I mean, again, this is a repetition here, but our equipment, our T1 analog or channel bank technology can provide you this protocol emulation with this full protocol emulation with our test equipment, as well as we'll talk a little bit later about the next generation stuff. Okay, so our equipment can consist simply of a notebook PC, a T1 unit with the analog component associated with it, and some software. And we'll get into this a little bit later, but that's just sort of a rough idea. You can actually look at the webinar, the videos that will be on the webinar on our website later to see how this equipment actually operates. Here's a quick picture of what this looks like. Okay, so our T-Pro, that's what we call it. It can be controlled by a very simple computer, notebook PC. It can generate up to 24 CAMA trunks and provide that CAMA protocol emulation and talk directly to a selective router. So in this method, we can test the selective router or the gateway, for example. Let's assume that the selective router is actually a gateway which interfaces to legacy T1 CAMA, but on the other side, it's a PSAP that is the next generation, like a SIP PSAP, for example, that I showed you in an earlier picture. You could use this for emulating legacy T1 CAMA trunks. In addition, so if and this emulates all of this information, so all the entire protocol, and it does it in simultaneously on 24 simultaneous channels, 24 time slots of a T1. Okay.
So just to follow up, I mean, DJ, what you're saying there is that protocol emulator is sort of emulating 24 emergency callers, right? Calling in.
Yeah.
Okay.
Mm-hmm.
So
yeah. For load testing and for just testing the selective router
testing and things like that.
Feature testing, right? Yeah. Exactly.
Okay.
Right. So that's and we implement that full. We'll kind of show you in either the video if we have time or through some ladder diagrams how that actually works. But you can emulate simultaneously up to 24. Well, in this case, you can actually. There's 2 ports on a T-probe, so you can actually emulate 48 CAMA trunks simultaneously, and you can emulate the feature set of a selective router and through scripts and that type of functionality. We can also do that. It's possible that the selective router or the PSAP has analog trunks, 2-wire analog trunks, and in that case, you would need to emulate the actual analog facility, and you'd have these 2-wire analog lines that I talked to you a little bit earlier about, where you have to emulate reverse battery and minus 48 volts and so on. You have to emulate the actual analog capability, and we use a channel bank to convert T1 to the 24 individual analog 2-wire trunks, and thereby we can essentially duplicate in the analog world what's happening in the digital world on a T1 line. So that's one method of testing analog. I hope that's clear. We can also test individually. Our T-probe also has an individual analog trunk where it can emulate a CAMA trunk as well, and in addition, it can emulate. It can monitor the actual CAMA protocol, the analog protocol, and the analog voltages.
So this is showing it can be the FXO port. So this is the emergency caller, a single caller, correct?
Right. Yes.
Okay.
And I mean the FXO meaning it's the selective router. It's emulating a selective router calling into either the PSAP or the E911 switch, which has an FXS. So that protocol that I had mentioned earlier, where one would go off hook and the FXS side would provide a wink, and then you transmit caller identity information, which could then be used for a database lookup to get the street address and so on. So all of that protocol, that precise protocol for conveying that information, can be tested on a single analog port using just the T-probe if you didn't want to go about procuring the channel bank and all of that. Does that answer your question, Matt?
Yes, that's. I want to make sure. Yeah.
Okay. Now, of course, you could do that. I think we also talked about many times. We don't get down to the analog level, and everything is handled digitally, although it's not necessarily the case. But when it is purely digital, then the protocol it transpires over the T1, and the CAMA protocol is easily emulated simultaneously on 24 or 48 trunks. And you can emulate this and use it for load testing and those types of things. Okay. All right. Now, the other thing that is happening on analog, when you're doing analog, anything analog, you need to make sure that, remember I mentioned that an analog trunk, we're talking about continuous signals there, and we need to be able to, I'm sorry, this is what I wanted to show you. Monitoring of CAMA type trunks over the analog facility. If there's an analog facility, we are monitoring the 2-wire analog line, and we're connecting directly to the 2-wire facility, which has minus 48 volts and is carrying that information out in actual multi-frequency tones, and we're able to monitor the voltages because many times there could be problems with the actual analog facility and the quality of the analog facility, the voltages, and the diagnostics. So one of the things that our RT probe does is it gets down to that level of detail where you can actually, through high impedance, monitor the actual analog facility. And it will provide you voltages and decode the tones and so on. And here's a typical output of our call monitoring process, where we're monitoring both directions of a CAMA trunk. Here, if you want to go through this thing in detail, this is idle. This really means that we're neither side is off hook. And when one side, the FXO side, for example, goes off hook, that means that we are, as I mentioned, this off hook, on hook is conveyed via reverse battery. Here, since it's the FXO side, we're basically going off hook, and this wink is what is used for reverse battery. That's why the term RB is here. And the wink is usually a short duration, about a couple of hundred milliseconds, that conveys that the actual calling number, it can be conveyed. So this is a protocol. There's two machines talking to each other. The information has to be conveyed, has to be signaled, and it has to be conveyed. And then this ringback tone is sort of an indication to the caller. Actually, behind this FXO line is the actual caller, the distressed caller. So he can hear this ringback tone and know that the actual attendant is being signaled. And as soon as that person picks up, you get the off-hook indication, and you have a voice path. So this is how the actual protocol takes place. Obviously, the first thing that has to be done is a caller has to be able to talk to an attendant, a PSAP attendant, by voice communication and convey the distress message, and then the proper emergency vehicle can be dispatched. So that's sort of the process. And many times we've found that there could be a problem especially when in this new technology, when you're trying to implement gateways and you have to convert from one technology to another. PSAPs, for example, may still be analog technology, because the PSAPs are governed by state governments. They have limited funds. They will, they have to budget their funds to migrate or transition to the newer technologies. So that's a sort of a long, drawn-out process. And more than likely, what will happen is the carriers will be converting to IP, and will be, or the wireless carriers will convey this information to a gateway where perhaps via SIP, Session Initiation Protocol, but eventually it has to get to the PSAP attendants, and if they haven't converted to the newer technology, you have to convert it from Session Initiation Protocol to legacy analog technology. And there, these are essentially new implementations, or new engineering implementations, and you have to make sure that these things are following the behavior of the CAMA protocol precisely, and not only in terms, in terms of voltage, in terms of distance, This two-wire technology has a lot of electrical characteristics to it that you have to follow. And this is where this type of capability of our instrument is useful. Okay. Okay. So so here's another picture of how the same tool can be used to understand the voltages that are taking place over the two-wire line. And this is described in our video a little bit in greater detail. I won't dwell on it here, but it is kind of interesting. If you're an electrical engineer, you want to understand how this is happening exactly, and you're involved in the design of these circuits or whatever, this would be a useful tool. Okay. All right, so next thing that we're going to do here is go through some demonstrations. I'll see if we can. Okay, we're actually going to go into the next generation NG911. Let's spend some time on that first. Okay, the next generation 911, as I had mentioned earlier, is a mandate of the FCC that all carriers, all PSTN VoIP wireless carriers, provide 911 services. Especially that these next generation 911 networks also be compatible with the next generation technology, which are promulgated in these NENA I3 standards. And those standards are, the basis of those standards are this new ways of conveying information, which happen to be multimedia. That means voice, of course. You have to have voice communication. The distress caller must be able to talk to the attendant via voice and convey the message that they want to convey. But in addition, there are, because of the frequency of use of mobile phones and VoIP phones and so on, people are using texting. In fact, I think majority of users these days prefer to text rather than talk. So texting is very important, and especially for hearing impaired and those types of individuals that are disabled, this multimedia capability is more important. So the FCC has mandated that these new networks be compatible with the newer technologies that are at the handset, at the actual user. The users are rapidly converting to the newer technologies. The carriers and the PSAPs are slower in migrating. I mean, the PSAPs are. The carriers are trying to keep pace with the users. And that's a competitive aspect. So this multimedia, even video, are part of this these standards for conveying this information. And of course, this text to 911 services is very important as well, because that's actually happening as we speak. What I understand is that the FCC has said that any area, any subscriber that requests text to 911 services for their region, the PSAP vendor must comply with that within 6 months. That was the wording that I read from the FCC. So these are all certain mandates that pushing the technology into the 911 space. Okay, so here is what we have to offer, GL Communications has to offer in terms of testing NG911 services. As I had said earlier, the most important thing about the next generation is that the standards have identified the NENA standards, NENA I3, as the methodology for this newer technology, this multimedia, carrying the multimedia information. And so that is carried through the session initiation protocol. So all of these carriers will be getting their location information the way they do that now via their protocols. whether it's legacy protocol or their wireless protocols for 2G, 3G, 4G networks, and convey that information or embed that information in the session initiation protocol, either the voice, or the texting, the media, the instant messaging, and all of those multimedia forms have to be embedded or have to be provided via session initiation protocol. And that goes into this, that's the edge of the network, and that goes into the what is called the ESI net. That is the IP, the core IP network that is going to transport this, that has the databases for that information. It will be querying those databases and providing that information to hopefully next generation PSAPs, which will be compatible with IP. So our products here that come into play, and I'll be getting into that, are SIP-based products that allow you to customize and script these new services and test them according to the NENA I3 standards. Eventually, the network will all be based around this technology, and you won't have to deal with the two-wire technology, the legacy technology of conveying only calling number. You'll be able to convey information more than just calling number. You'll be able to convey additional information about the distressed end user, which could be, a variety of pieces of information, not just the actual location, but it could be information about the caller himself, about emergency addresses, and not only his exact location, but his additional information that will help the call taker to make a more informed decision about dispatching emergency services. Okay. So here are some of the requirements. I'm not going to go into this too detailed. We have some videos, short videos that will get into this a little bit more. But essentially what we're talking about is being able to test voice quality, test SMS instant messaging, test this texting or instant messaging. MSRP, for example, second bullet is the instant messaging capability that, or texting capability that is already part of our suite of protocols, and that's the protocol that is being promulgated by the standards bodies to convey text information. We can also, of course, as you know, VoIP networks or wireless networks are based around different voice codecs. Some of them are higher quality codecs, like, for example, AMR wideband. Some of them are lower quality, narrow band, and there's also discussions about super wideband. So testing the performance of these networks, the voice quality performance, and so on are also part of our test suite. And to actually test the protocol, any machine-to-machine communications is very protocol intensive, and they have to go through a very precise state machine. And so what our tools allow you to do is to exercise that state machine so that it is error-free, and that it is validated, and that it conforms to the protocol specification. So our tools in this arena, SIP arena, allow you to customize or do conformance testing. So that's what we're trying to say here, and we can do that either through GUI-based techniques or API techniques, and that's what we're saying here. Finally, the speech quality. I think I mentioned that earlier. When there, of course, quality of communication between a distressed user and an attendant is probably very important to try to get the exact message across. And the better the voice quality, the better the communications is. Okay. So again, this is just a reiteration of what I said earlier. Our MAPS, we're using the special term here, MAPS, M-A-P-S, the trademark name of ours. It stands for Message Automation Protocol Simulation. Mouthful, but it means that it's our platform for emulating protocols, precisely the state machine. That's the platform that we use for a variety of protocols, including Session Initiation Protocol, SIP. And there we're using that to emulate NG 911 services, whether they be voice, instant messaging, texting, or any other form of media. And we're able to use that platform to do the protocol conformance or load testing or feature testing. Here's a typical IM simulation, instant messaging simulation with, I think, the protocol that I had mentioned, which is MSRP, which is part of our session initiation protocol. And it's sort of your conventional SIP protocol, but with embedded information about the instant messaging session, MSRP session, message session relay protocol. MSRP stands for Message Session Relay Protocol. So that's as part of our SIP suite of protocol support. Here's the actual implementation of that with our own GUI. You can see here, and then there's a video to support this that goes into the details of how this is done. We get into all of the message exchange, and you can highlight a particular message and see the details of that, and so on. I am only call generation. This is, again, instant messaging, MSRP. Okay, so Matt, do you want to take over here?
What we'll do here is I will quickly go through just a couple slides just to give a flavor for what we're doing. But we're introducing something here which we've had for a while, but I'm introducing it in this webinar. What we're calling it is NetSurveyor Web. And as VJ was mentioning, we have these products called MAPS to emulate and simulate many users in the IP SIP world, and so forth. We also have a product called Packet Scan, which is a sort of non-intrusive monitor product that is monitoring all of this communication, all of these protocols, and can give you very detailed look into the protocol sequences, the message decodes, as well as provide voice quality statistics on the RTP packets that are being used in the VoIP world. So all of that sort of monitoring information can be fed into this other product that GL has called NetSurveyor Web. And I won't get into all the little things here, but I kind of explained it to you. But NetSurveyor Web is essentially a database of information that these monitoring points throughout your network would be feeding. Okay, so this database is sitting there, and maybe you've got 2 or 3 monitoring points in your network. So those monitoring points are going to be sending all of the information that they're seeing at that location, at that point in the network, back to a database, and that database is storing it all. The mining of the database is done through this application we call NetSurveyor Web. So the database has all the information, all the protocol information, all the voice quality information, all the information about the network that you're monitoring. And this NetSurveyor Web interface is allowing you as a user to look into that database and pull out all of the information you want to see and organize it nicely, put it on the screen, create reports, create graphs, create logs, and things of that nature. So that's the concept behind the NetSurveyor Web, and a few screenshots here show you how we're kind of doing that in a graphical manner. This particular one shows a certain call where we've recorded the voice file, and you can play that back so you can listen to what's going on. As I mentioned, the NetSurveyor Web has all of the nitty-gritty information about the protocols, so you can see the ladder diagrams and the decode. This in particular is a legacy sort of CAS protocol on a CAMA trunk. As I showed earlier, this is just a reiteration of it, but you basically in the SIP world, in the voice over IP world, all of those calls that are coming into the PSAPs and so forth through that network, through that IP network, are being monitored by our product. And this is showing on the screenshot to the right certain calls where you see each direction of the call and how many packets were sent. This is again in the IP world, the missing packet count. So all of the quality information about those calls, the time that the call happened, who called who, and so forth. It's all being shown here. Just another way that we're showing that. We have many graphs, as I mentioned, related to the quality, related to how many calls maybe the PSAP was seeing, different times a day, and so forth. And one other mention that I'll say about this NetSurveyor Web, it has the ability to notify you as maybe the network administrator or the technician of the network when events happen, so events of interest. You can set up triggers, we'll say, when certain things happen. Let's say your voice quality drops below a certain threshold, or you receive an abnormal amount of 911 calls in a certain duration. So for 5 minutes you receive a huge spike in the number of callers calling in. These types of conditions can be defined, and the NetSurveyor Web can alert you through different means, through emails, through text messages, through audible alarms and visual alarms. So you can set up these scenarios where they can be sort of admin related things where maybe over a 24-hour period if my voice quality was low, or they can be very real time in the sense that over the last 5 minutes I've received 50% or 100% more calls than on average that I receive in 5 minutes. So those types of scenarios, you can sort of dream those up, and this product, this NetSurveyor Web, can alert you as a user of the system. Again, some of those things, it can email you and it can send a report. So what I'll say now, since we've exceeded our allotment of time and we want to get to a few of the questions, we've got in our webinar here, in our presentation, we have a few demos or videos. We won't go through them at the moment, but I will tell you that they will be posted on our website, and you can go back and look at those, and that will show you how our software is run and some of those features that we've been talking about. Sort of in conclusion, before we start taking some questions, GL's products are sort of organized in the emulator world as well as the monitoring world. So we're emulating CAMA trunks, we're emulating voice over IP SIP callers with our MAPS product, and Vijay showed a lot of that. We also have the ability with that T-probe and with the packet scan to be monitoring, so non-intrusively monitoring these circuits and these connections. And we can show all of the information from a non-intrusive analysis perspective. And that's what NetSurveyor Web, which I just showed you, kind of brings together. So those are fundamentally, those are where GL lies in the test equipment for this industry. A lot of these demos that we have on here can show you a little bit more detail into how we exactly do it. But at this point, I think since we are over our time allotment, let's Sanjeev, if you can jump on and maybe ask a few questions that maybe have been raised, and we'll go from there.
Thank you, Matt.
Yeah, sure.
We have questions raised by a few customers. I'm asking, who controls or owns the selective router?
Well, selective routers are usually they're carrier owned because it is a responsibility of either the VoIP carrier, the PSTN carrier, or the wireless carrier to either provide a gateway to the selective router or provide the selective router if it is in their totally in their domain. So I would say that my first answer would be that it's the carrier responsibility.
Thank you, Vijay.
Everybody, thank you for attending. We appreciate your time, and check our website for next month. We'll have another topic, and we'll have another webinar in a month or so. Thank you.
Thank you, Vijay.